There you go.
We'll just cut this, right? Okay. So our extra credit assignment was on the Mars ascent vehicle from the Martian. And so kind of the basic things of how this technology works, essentially ascent vehicles in general, is that they require thrust to both lift off from a planet and to land safely onto it. They have a crewed compartment, and this compartment's either pressurized or unpressurized, and those come with their own advantages and disadvantages. For example, a pressurized compartment does not require an EVA suit, but it's also heavier because you have pressurized doors as well as an atmosphere. Whereas unpressurized, you require an EVA suit, but it's lighter, but it's also riskier because you have issues with dust contamination, as well as you're dependent on an EVA suit for survival. And realistically, these ascent vehicles are designed to be crewed for 12 to 24 hours, or at least specifically for a Mars ascent vehicle, because that'd be plausible time for rendezvous with the larger craft that deployed the ascent vehicle originally. And next portion.
So we've already had some experience with ascent vehicles during the Apollo missions. We had the lunar ascent vehicle, which was only a 2-crewed vehicle, and it just sat above their habitat module. It was only the difference mainly being that the gravity on the moon is much less than that on Mars, and so it only requires a 1-to-1 gear to propellant ratio, while on Mars it would take a 7-to-1 propellant to gear ratio. So we thought that it might be a little bit unlikely that a 6-person module would be able to work very well on Mars. In the facts that we researched, we found out that if you were to increase the crew from 2 to 6 on Mars, that would add an extra 330 kilograms of gear, and that is equal to you would have to add an additional 2,750 kilograms of propellant, which is quite a lot to bring from Earth, land on Mars, and then also take off. It's quite the challenge. The TRL level for this kind of technology is probably about a 5 for the Mars ascent vehicle. It's obviously at a 9 for the lunar ascent vehicles because we've already done it and tested it multiple times. But we're in the technology development and technology testing. We're starting to test some subsystems together. And so it's probably at about a 5 or a 4 on the TRL scale.
For our opinion on accuracy, we consider that the Mars ascent vehicle is only designed for ascent and not habitation. So at least in the movie, they had to reduce the mass on the craft so we could launch the vehicle into orbit, and so they could meet the rest of the crew. So it's within plausibility, considering that there weren't any other crewmen, and there was a big reduction in weight, so it was very drastic.
Alright, and finally, just in reference to the end of the movie, where Mark Watney has to launch off of the Ares 4 ascent vehicle, the TARP would be feasible in the case of the Mars launch because of the Martian atmosphere being less than 1% the density of Earth's. And going off of that point, because the Martian atmosphere is at such a small density, the storm in the beginning of the movie very likely could not have been possible, as a 60 miles per hour wind on Mars would be equivalent to about a 6 miles per hour gust of wind. Hence, the movie shouldn't even have taken place.
That was a good movie anyways.
It was good.
It's a good movie.